This is lesson 8.5, page 450. In this lesson, you will learn about intercept form quadratics. The four major points that we will cover today. You will learn how to graph an intercept form quadratic. You will learn the relationship between intercept form quadratics and zeros of functions. You will learn how to use the characteristics of an intercept form quadratic to write a quadratic equation. And you will learn how to use the characteristics of an intercept form quadratic to write a cubic function. First of all, we got to figure out what the heck is an intercept form quadratic. It looks like this, okay? You've already learned how to graph quadratics written in different forms, like standard form and vertex form. Now, you learned about standard form quadratics in lessons 8.1 through 8.3. In lesson 8.1, you learned what A meant. In lesson 8.2, we taught C. And in lesson 8.3, we looked at, when we had a B value, how the axis of symmetry shifted. In lesson 8.4, the previous lesson, we learned about vertex form quadratics. Okay? Quadratics can also be written in what's called intercept form. This form is factored form. So here we're going back to chapter 7, factoring again. This is in factored form, and when an equation's in factored form, it's easy to find the x-intercepts. So, intercept form quadratics look like this. So what does that tell me? First of all, the x-intercepts are P and Q. So these two numbers will tell me the x-intercepts of my graph. Now remember, the x-intercepts are the points where the graph crosses the x-axis. So these two numbers would give you these points of my parabola. The axis of symmetry is halfway between points P and Q. So the axis of symmetry can be found by averaging P and Q together. So the axis of symmetry is the average. Now to find the average of something, you add those things up and divide by 2. That's what this little thing is telling you. Find the average of P and Q and you got the axis of symmetry. The A value, it tells you the exact same thing it told you back in lesson 1. If A is positive, the graph, the parabola opens up. And if A is negative, the parabola opens down. So the A value is consistent no matter what form I have. A always tells me if the graph will open up or down. Now, a couple things we got to be really careful about. Remember that when we have transformations outside parentheses, that's vertical. These are inside parentheses. These are horizontal translations. So, and this is another key thing, anytime it's inside, it's always backwards from what it looks like. That's really important to remember. Let's look at an example here and do one together. Let's look at this problem. Let's graph this function that's in intercept form. So here's the first thing. You see how we have inside a +1 and a -5. Okay, these are horizontal translations. So +1 really means -1 because it's backward, and -5 really means +5. So look at what we did. We plotted the point -1, 0 and +5, 0. We plotted those 2 points. Here's the next thing. In between those 2 points is the axis of symmetry. So if we average out these 2 points, let's average out -1 and 5. If I add those together and divide by 2, I get 4 over 2, which is 2. The axis of symmetry is 2. So you can see on this picture here, they put a dotted line at x equals 2. Now think, what special point is always on that dotted line? That axis of symmetry. I hope you're thinking, well, it's Mr. Lemansky, it's the vertex. You're right. The vertex is on the axis of symmetry. So right now, if the axis of symmetry is 2, I know the vertex is 2 and some unknown amount. Remember, this is x, this is y, so I don't know y. It should be really easy to find that. Take your equation, f of x equals the opposite of x plus 1, x minus 5. Take 2 and plug it in for x and figure out what, remember that's y, figure out what y is. So y would equal negative, I have 2 plus 1 is 3, and 2 minus 5 is negative 3, and 3 times negative 3 is negative 9, and I have the opposite of negative 9, which is positive 9. Y must be 9. So the vertex is 2, 9, which is what they have here. So I can go 2 right and 9 up and plot that point, and you can see there's my parabola. I ought to be able to easily draw a parabola based on that information. They also want the domain and range. The domain, I can plug any number in for x, so the domain would be all reals. The range, let me take a marker. Do you notice how the highest this graph goes is 9, and it just keeps on dropping? The range, the highest that can go is 9. The range would be y is less than or equal to 9. Let's do another one. Let's graph another quadratic. They want me to graph this and describe the domain and range. Now, the book, they change this into intercept form, but I don't know that I agree with that. Look at this. This is in standard form. This is exactly what you learned about this is a lesson 8.2 question, really. Okay? This is really a lesson 8.2 question. A is 2, so I know this opens up. C is negative 8, so I know I can translate my vertex 8 down. So let's go to the picture. They translated the vertex 8 down. I know this is opening up, and I need 2 other points. Now, they factored to find 2 other points. You notice they took the greatest common factor out. They divided both these by 2, and they saw that we had a difference of squares. So this would turn into x plus 2, x minus 2. That's in intercept form. They went ahead then and said, okay, I know my 2 intercepts. One's negative 2 and one's positive 2, so they graphed those points, and they used that then to create a parabola, really without a calculator. Okay? I would let you use a calculator on this, so I personally probably would have just kept it in standard form and just graphed it from there, but it's what I'll do on a quiz or test. I might ask you, what are the x-intercepts of this graph? In that case, you would want to be able to factor it so you can put it in intercept form. Okay? Why don't you pause the video right now? I would like you to try number 1. Try this without a calculator, because if you just plug it in, it doesn't tell me you really understand anything about intercept form. Try graphing this without a calculator. It's written in intercept form as you see it. Okay, and I'm back, and so this is in intercept form, which means the x-intercepts, can you see, remember, inside backwards, it's horizontal and backwards. So the x-intercepts are negative 2 and positive 3. So you can see I plotted those. Maybe I should make them a little bigger. I plotted them. I'll make these bigger so you can see that. Okay, now, I need the axis of symmetry. The axis of symmetry is the average of those 2. So I'm averaging out negative 2 and 3. Negative 2 plus 3 is 1, and I divide that by 2, and it's a half. So my axis of symmetry is a half. Now, my vertex has to be on the axis of symmetry. So I know my vertex is half for x, but I don't know y. Okay, it's easy to figure out y. Take 1/2, plug it in for x, and figure out y. So I'm going to do that. If I plug a half in here, I get half plus 2 is 2 1/2. If I plug a half in here, half minus 3 is negative 2 1/2. And if I multiply those together, I get negative 6 1/4. So there's my vertex, and you can see I graphed it down here. Can you see my parabola? I just have to graph it, and there you go. I now need the domain and range. I can plug anything in for x. My domain is all reals. The range, can you see in the picture? The lowest my graph goes is negative 6.25, and it just keeps on rising. So my range would be y is greater than or equal to negative 6.25. You can use intercept form to find zeros of functions. In lesson 8.2, you learned the zero of a function is the x value that would make y 0. You can use intercept form of a function to find the zeros of the function. Okay? Now this is vocabulary. It says functions have zeros and graph has x-intercepts. These are both just telling you the same thing. They're saying both of these are saying that it's an x value that makes y 0. Okay? So when you look at the sample question, find the zeros of this function. That should be easy. I'm trying to find out what value for x makes y 0. So you notice they replaced y with 0. Now when I say y, remember f of x and y are the same thing. They replaced y with 0. Let's solve this. This times this is 0, which means one of these has to equal 0. So if I add 1 here, add 1, x equals 1, and if I take away 2, x is negative 2. So the zeros of my function are negative 2 and 1. So if I look at them on the graph, I'll see a x-intercept at negative 2, and I'll see an x-intercept at positive 1. Another core concept, factors and zeros. For any factor x minus n of a polynomial, n is a zero of the function defined by the polynomial. Now, as the math teacher, as I read that, that sounds confusing. This is all it's trying to tell you. This is a fancy way or a technical way of saying the solutions you get using the zero product property are zeros of a function. Now, you use the zero product property constantly back in lesson or chapter 7. Okay? When you use the zero product property and get answers, those answers are zeros of a function. Okay? So, this stuff that we're using here is just a great review of what we did in chapter 7. Let's look at these two examples real quick. Find the zeros of each function. So let's look at this problem. Oops, look at what they did first here. Sorry, my pen just went haywire. So they took this greatest common factor first, GCF. They factored out negative 2. Okay, so I'll put GCF. Look at the trinomial. What times what 6 and adds up to 5? Well, 3 and 2. We're making this equal to 0. So we know x plus 3 has to equal 0, or x plus 2 has to equal 0. And if I take away 3, one solution is negative 3. And if I take away 2, another solution is negative 2. That's why negative 3 and negative 2 are called zeros of this function. Look at B. Look at this sample. Have I factored this completely? Well, look over here. I have a difference of squares. I can factor that into x plus 4, x minus 4, and these are equal to 0. So I immediately know in this question, x minus 1 could be 0, x plus 4 could be 0, x minus 4 could equal 0, and that's why I'm getting these answers, because this would give me positive 1 for an answer, this gives me negative 4 for an answer, and that gives me positive 4 for an answer. What I would like you to do real quick is try 4, 5, and 6. Pause the video and find the zeros of these functions. Okay, and I'm back. In number 4, it's already factored for you, so this is pretty easy. Make y 0 and solve. You get 6 and 1. In number 5, you have to get the greatest common factor first. So I factored out the 3. And look what I have. I have a perfect square trinomial. That's an easy one. X minus 2 to the second power would double distribute into that. So x minus 2 would have to equal 0. X equals 2. This is a double root or a repeated root here. I'm getting 2 roots of 2 for that. And then in number 6, I have a difference of squares here. So x squared minus 1 would factor into x minus 1, x plus 1. So I have 3 solutions here. X could equal 0, x minus 1 could equal 0, or x plus 1 could equal 0. So my 3 solutions are 0, 1, and negative 1. Now we can use zeros to help us graph a quadratic. So when they say use zeros, what does that mean? It means we want to use x-intercepts to help us graph the quadratic. So when you look at this, I don't know what the zeros are, but if I factor it really quick, I would know them. So I got to think, what times what's negative 3 and adds up to negative 2? Well, let me see. Negative 3 and positive 1 do that. So look what they did. They factored this. Okay, so my zeros. My zeros would be negative 1 and positive 3. Remember, these are backwards from what you see. So you notice they graph negative 1 for x, positive 3 for x. And that will help me draw a parabola through these points. Okay, so I can use zeros of a function to help me graph a parabola. Now everything I've learned or taught or hopefully what you're learning here can help you write a quadratic now. Okay, so let's look at writing a quadratic in standard form whose graph satisfies the given condition. So this first question, they want me to write a quadratic whose vertex would be negative 3, 4. Now, since I know vertex form, and this problem has a vertex, let's start in vertex form. Okay, I know that x is negative 3, y is 4. Now, remember, same thing applies here. This is going to be backwards from what it looks like. So when I see negative 3, it's really positive 3 here, positive 4, and I'll just make a1. I just want to write a function in standard form that would satisfy these conditions. Okay, so let's write standard form. So the first thing I need to do is take x plus 3 and square it. So let me do that. X plus 3 squared would be x squared plus 3x plus 3x plus 9. So this is x squared plus 6x plus 9. So I have, you can see that's where we're getting this. And then I have the plus 4 at the end. And 9 and 4 is 13. So there would be a function for this situation written in standard form. Y equals x squared plus 6x plus 13 would be a function for this problem. In part B, this is giving me intercepts. I got a graph passing through 9, 0, negative 9, 0, negative 2, 0, and the point negative 4, 20. So this is intercept form. So let's start off with intercept form. So you notice that's what they do. They start in intercept form. There's an intercept form quadratic. Remember, since this is horizontal, it's backwards from what it looks like. That's why you see a plus 9 and a plus 2 in there. I got to figure out what A is. That's where this point comes in. X is negative 4, y is 20. So look what they do. Anywhere you see x, they put a negative 4 in. And y, f of x, has to be 20. I can use this to figure out a, and then I have my equation. So 20 would equal a times negative 4 plus 9 is 5, negative 4 plus 2 is negative 2, 5 and negative 2 is negative 10, so let's write that down. 20 equals negative 10a, and if I divide by negative 10, that's why they're getting a is negative 2. So now I have my equation. If a is negative 2, I can plug that in, and my equation would be y equals negative 2, x plus 9, x plus 2. And now all I got to do is finish this up. They want it in standard form. So let's quickly double distribute and simplify. I have a negative 2 out front. I have x squared plus 2x plus 9x plus 18, so that would be y equals negative 2 x squared plus 11x plus 18, and if I distribute the negative 2 through, I get negative 2x squared minus 22x minus 36, and you see that's matching what they have here. What I would like you to do is pause the video. I would like you to try numbers 7, 9, and 11 here. Okay, I'm back. So for number 7, they want us to graph this intercept form quadratic. So first of all, you notice it's an intercept form. Intercepts are 1 and 4. Remember, these are backwards from what they look like. So you can see I plotted 1 and 4. The axis of symmetry is in between those, so I have to average them out. 1 plus 4 divided by 2 is 2.5. There's my axis of symmetry. Now I got to find my vertex. I know my vertex is 2.5 comma something. I put 2.5 in here and 2.5 in there, and I got 1.5 times negative 1.5. That'd get me the negative 2.25. So there's my vertex, which you can see I plotted, and there's my graph. In number 9, they wanted me to write in a function in intercept form. They told me the intercepts were negative 1 and positive 1. So remember, I got to write this backwards from what it looks like. Okay, so I made A1, this is for negative 1, there's for positive 1. There would be an equation in intercept form for that quadratic. Now I just have to finish writing it in standard form. So let me do that real quick. I have x plus 1 times x minus 1, and I'm going to double distribute, multiply this out. So let's do that. I get x squared minus 1. There would be my standard form for number 9. And then number 10. Okay, in number 11 I meant to say. They want me to write an equation in standard form for the graph under these conditions. So they told me, looks like I did number 12, not number 11. Shoot. Let me fix that real quick. Okay, I fixed it here. So here's the work for 11. My intercepts are 0 and 10. Now remember, it's going to be backwards from what it looks like. I don't know what A is, though. So I can take the point for 12. X is 4, y is 12. Wherever I see x, I'll put a 4 in. So 4 minus 0 is 4. 4 minus 10 is negative 6. And y, you see, is 12. So I need to multiply these together. Negative 24a would equal 12. Divide by negative 24, a is a negative half. So I'll put that in here. Okay? So negative half times x minus 10 would be my equation, but I need to simplify that. So I'm going to distribute. There is an equation in standard form for the information they gave me in number 11. The last thing to cover in this video is how to graph and write cubic functions. Now, quadratics are second degree. Cubic means third degree. So when you have cubic functions, you're going to have 3x intercepts. That's what this is trying to show you here. You're going to have 3 sets of x intercepts. Okay? So let's take a look at doing that. Okay, so use the zeros to graph this cubic function. So let's go ahead and do that. Let me highlight what we're looking at here. Right here, we want to graph the cubic function. So first of all, to know the zeros, I'm going to have to factor this. Let's factor it. My greatest common factor here is x. Let's rewrite that. F of x would equal x. I'm factoring that out, x squared minus 4. Do you notice the difference of squares here? So f of x would equal x and x minus 2, x plus 2. So my zeros of the function, that could equal 0. This could be 2, and this would be negative 2. Those are my zeros. So I'm going to graph those. Negative 2, 0, and 2. So negative 2 for x, 0 for x, 2 for x. Now here's the next thing. The lead coefficient is positive. Anytime you have a positive lead coefficient on a cubic function, that means your graph is growing. It's starting low and finishing high. So I can start low, and I just keep on passing through these points, and it finishes high. All cubic functions have this roller coaster look to it. Okay? We can write a cubic function using the same techniques we did in about 5 minutes ago on my video for quadratics. This graph represents a cubic function. Write the function. So look at the intercepts. 0, let me highlight them here. 0, 2, and 5 are my intercepts. Look what they do. They write y equals, you see how they put 0, 2 and 5. Now remember, these are backwards from what you see here. That's why they have the negatives. Okay? Next thing. This graph has the point 3 for x, 12 for y. So look what they do here. Anywhere they see x, they put in 3. Anywhere they see y, they put in 12. And now we just have to solve this. Let's solve it. I'm going to show the work the book doesn't. 12 would equal a times, this is 3. 3 minus 2 is 1. 3 minus 5 is negative 2. So 12 would equal, multiply those together, negative 6a, and I'll divide by negative 6. A is negative 2. That's where they're getting this from. So all they do is they take a, put a negative 2 in. There's my function. Now they want me writing it in standard form, so now we just have to do that. So I'm going to do the work here. Let's work it out. So I have negative 2x, and then I have x minus 2, x minus 5. Let's take these two and double distribute. I'm going to do that first. So I have x squared minus 5x minus 2x plus 10. So y would equal negative 2x and x squared minus 7x plus 10. And then I have to distribute the negative 2x through. I get negative 2x cubed plus 14x squared minus 20x. That's where they're getting this from. Okay? I'm going to I'm going to stop the video here. I've covered everything we need to cover. If you have any questions, make sure you ask in class.